All right, let's go ahead and talk through some of the information necessary to complete the module folder 1A pre-lab. This pre-lab is a little bit different than most of the rest of the ones that we have in that there's not a simulation or outside source that goes along with it. One of the biggest things that we have to pay attention to in this pre-lab assignment is listed out in almost every question, 0.01 centimeter precision. So precision means basically the last useful decimal place in a measurement. And over again, that's going to be mentioned here. So again, 0.01 centimeter precision. Here again, so with each different student, with each different measurement, we're looking at that same level of precision. What we want to think of and what we need to keep in mind for this is that any of our measurements that we take using this format, we're going to have whatever whole number, potentially multiple whole numbers, and then 2 decimal places, and then a cm for centimeters. Essentially, what you want to keep in mind with this is that means that if we properly take a measurement using a tool with this precision, is that we're going to get a number that kind of looks like money with the 2 decimal places, but it will have centimeters at the end instead of a dollar sign. And in fact, you can get through about 2/3 of these questions by only paying attention to this fact. So let's see if we can pick through and find a couple of those. Okay, it's like the first one. We don't know anything. There's no real pencil. There's no real person. This is just a completely theoretical, hypothetical type question. But which one of these might be an appropriate measurement, keeping in mind what we just said about 0.01 centimeter precision? Well, if we look at the first one, it does have the centimeters like it's supposed to, but it only has 1 decimal place. And then the next one has 3 decimal places, which is too many, and then it has mm for millimeters. So that doesn't make sense for our precision. The next one properly has 2 decimal places, but no units on it at all. So that could be centimeters or that could be light years, and we have no way of knowing the difference. So the only one for us that makes sense is 17.94 centimeters. Now that's actually going to end up being really important for the rest of this because we're going to take that to be basically our control number. Essentially, that means the answer that we expect to be perfect or correct. We're going to compare everything else back to this number. And eventually what we're going to do, and we're going to have 3 sets of these, but we're going to find a percent error of some new measurement compared to this. And the formula can be shown a few different ways, but basically we have our trusted number, which is the one that we're going to see here, subtract the number that we're testing, so our test number, divided by the trusted number again. So keep in mind that the number you trust more is the number that you use twice. So in each case, that's going to be here. Now, what this is going to do, the top part's going to give you a raw difference or absolute difference depending on exactly how you interpret the steps. Then dividing is going to give us a decimal. For percent error, you'd have a final step where you'd come back and you'd multiply by 100 and slap a percent sign on it. Okay, so let's think through the rest of these questions in the context of this formula as a goal. Okay, so in the next question, what might reasonably be a measurement that another student took? Again, these are randomized numbers, fake student, fake pencil, fake lab. None of this is really happening, but we want to make sure that we're following our rules in our type of measurement here. And so I think it's obvious that, again, we have some of the same problems. Excuse me, and even, some similar numbers. This one, first one doesn't have any centimeters on it. Next one has too many decimal places in the wrong units. The next one has the right units, but only 1 decimal place instead of 2. And so if you look, we had 17.94 on this one and 17.64 on this one. Okay, so let's keep going. We've got a control answer. We've got an answer for student A or pencil A, depending on how you want to label that. Then let's keep going again with the ultimate goal, trying to find percent error. So the next part, what is the absolute value of the difference between pencil A and the control pencil? So this was our trusted number, the one that we got on question 1, and then our test number, the one that we're questioning, we don't know what's going on with this one, is going to be our 17.64. Okay, so let's think about this. Absolute value of the difference means basically the top part of this formula. I want to subtract and I want to find an answer between these two. Now, absolute value means we don't care if it's too big or too small. We just want to know how much is it off. And so again, you can sometimes kind of think of the absolute value bars as being at the top of the fraction and not on the whole thing, because it'll end up being positive in the end anyway. Now, one extra thing you do have to pay attention to is that when we subtract those numbers, your calculator is going to give you this number, because your calculator doesn't understand precision or decimal places or significant digits or units. If you have a calculator that lets you type in centimeters and do something with it, let me know, because I don't know that I've ever seen one. Okay, so when we subtract two things that have two decimal places, we need to get an answer that has two decimal places. So our proper answer is going to be already narrowed down to just B or C. But we also have to keep in mind that if we're subtracting centimeters and centimeters, then we should have an answer that has centimeters. Okay, and so that's the difference. That's going to be basically the top part of this. Now we want to work down and see what it's going to be for a percent error. So from the formula, we find our difference. We use the top part of this fraction, we subtract, there we go. Then we're going to divide by our trusted number. Notice that that shows up twice in the equation. That's on purpose. And so if we do that, we're going to have 0.30. Your calculator's probably going to take the 0 off. We can't type in the centimeters, so again, we have to remember where this comes from. We're dividing by the number we trust, which from the first question was 17.94. So no wayward zeros that will disappear on that one, but we also can't type in the centimeters. Doesn't matter, because technically if we were to do centimeters divided by centimeters, the units would cancel anyway. Okay, so when you do this in the calculator, you're going to get 0.0167224, blah, 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 blah. It goes on seemingly forever, it looks like. What we need to keep in mind from that is that's just a decimal version of this answer. So looking back at the equation, that would have meant that we've finished this fraction, but we haven't paid attention to the times 100% yet. This is something that you may have learned in school, as find an answer and bump the decimal place. Technically, that's fine as a strategy. Where you've got to be careful is you don't want to accidentally bump the decimal place and multiply by 100. It's either or. The whole reason why bumping the decimal place 2 times worked in school is because times 100, there's 2 zeros in 100, and you're bumping it when you're making it bigger by multiplication. So if we take that answer that we just talked about, 0.0167, blah, 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 if we multiply by 100, it turns into 1.67. And then we slap a percent sign on it, because those are the units, if you want to call them that, on our answer. Okay, now I'm not going to do student B and student C, because essentially they're the same thing with just different numbers. So this should be enough to get you started, hopefully make you more comfortable with the process. You definitely want to be comfortable with finding percent error, because about half of our lab activities, if you're in person, involve finding percent error. And even if you're taking online, there are a number of activities that make you find percent error. All right, and that's it.